Alright, today's day 2 of Unit 8 on graphing quadratics. So yesterday we talked about graphing quadratics. Today we are going to continue that. First we're going to go over the homework from yesterday. So for question number 1, one of the things I wanted to point out was question number 1 did not have a C value. So remember, when something is not there, it is a 0. So this right here means that the y-intercept is 0. Okay? So again, you're going to put that in your graph. Look for that symmetry. Again, I always ask you to circle it. Okay? So your vertex is going to be the turnaround point right here. I see that it opens downwards, so it's a maximum. My roots are when y is 0, because remember, another word for roots are zeros or x-intercepts. Our domain is all real numbers, and then our range is y less than or equal to, because it's downward, and a positive 1, because that is the y value. Number 2, that one is x squared minus 6x plus 8. We have an 8, so even though I didn't graph that, so right up here would be another point. Even though I didn't graph that, remember, we can always tell our y-intercept by our C value. So our turning point is 3, -1. It is a minimum. It's concave up. Our roots, as we can see, so again, here is our vertex. Remember, our roots are it just so happens that these are both right next to the vertex, but these are just when y is equal to 0, because our roots are also called x-intercepts. And the domain, all real numbers. Y is greater than or equal to, because it goes up, -1, because that is the y value of my vertex. Okay, for number 3, it would be best to put them into your calculator. You're looking for the lower minimum, so we find the vertex. Okay, so we want the y value of the vertex. All right, so if I look at those, I would get 0 for g of x, and then a 4 for f of x. So my answer would be f of x has g of x rather, has the lower minimum. And lastly, we just wanted the domain when it is increasing. Okay, so for increasing, we have our turning point is right at 0. Okay, since it's a turning point, remember, we don't put the equal sign on it. Okay, so for decreasing, that would be less than 0. It would be decreasing. It's going down. Okay? Going down. Alright, so for today's lesson, we are going to start with question number 1, which asks us, which of these polynomials have the zeros of -4 and -6. So all I'm going to do is I'm actually just going to put these into the calculator. Okay? Trying to get that glare away. Alright, so for the first one, I have, let's see, x squared minus 10x minus 24, and remember, I want to see where they cross the x-axis. I see that this doesn't cross 2 times on the negative side. You can look further to see. So this is -2 already. It's not a -4. So I'm going to cross that one off. Okay. So go ahead and keep going down the list. All right. It could be choice number 4, but this doesn't take too long, so I think it's worth it. Okay, do the graph. Okay, so that one to me looks like, so it has 2 negative zeros, or negative roots, okay? I can count and see that it is -4 and -6. If you wanted to just double check, you can see -6, -4. That one did in fact work, so our answer is choice number 2. Okay? Alright, so let's do an example like we did yesterday. Alright, so go back to this. So we have x squared plus 8x plus 12. Okay, go ahead and graph that, get a general idea, and then go to the table. So once I go to the table, I want to look for that symmetry. Well, it just so happened they gave me the symmetry right away. So remember, I like to find the vertex, and then I like to go 2 above and 2 below. That usually gets me a perfect little curve. So I'll start with -6, 0, -5, -3, -4, -4, -3, -3, and then -2, 0. So what I like to do with this table is I like to kind of map out all the questions that I am actually going to ask you. Okay, so this is our vertex. When x is 0, this is a root or a 0, or an x-intercept and a root. Okay, so you can go ahead and graph that now. Okay, so here's what my graph would look like. Make sure you also label your graph. Alright, so we're going to skip the axis of symmetry for a second because that's our new one. So let's look at everything else. Now remember, this right here, our C value is our y-intercept. Okay, you can look on your coordinate or on your table in your calculator, but just remember that's when x is equal to 0. So that would be 12 or 0, 12. Our vertex is -4, -4. Our roots are -6, 0, and -2, 0. Okay. Our range, remember we write y. It's greater than or equal to because it opens upward. And then -4 because that is our y value of the vertex. And then this is a minimum because our vertex is at the lowest point. Okay. All right, so let's go back to the axis of symmetry. So as we talked about yesterday, a parabola or a quadratic is always symmetrical. So what I'm going to do is I'm going to go to the vertex, and at that point I am going to draw a vertical line. So the axis of symmetry needs to be an actual equation of a line. Okay? So this equation of this line is an x equals, and then whatever the value of the vertex is at the x coordinate, that is what the answer is. So x equals -4. That is the axis of symmetry. This is the equation of the line that goes through the vertex and is a perfect vertical line that if I cut on that and folded my parabola, they would be identically symmetrical. Okay, so let's kind of talk about that a little bit. All right, so the line of reflection or the axis of symmetry, and I don't think you have a lot of this in your on your paper, so this is just for informational purposes. Okay, so the line of reflection or the axis of symmetry is what makes the parabola symmetrical. So it's just like a mirror image. So if you were to look at the table, you notice that the x value of the turning point of the vertex is the axis of symmetry. All right? So the equation of the axis of symmetry is x equals -b over 2a. So please put that on your paper. Okay? So we can use this by finding the b and the a. Remember, our b and our a comes from standard form. So we know that the c gives us the y-intercept. Okay, we know that if a is negative, it makes it go down. If a is positive, it opens upward. But also the b and the a can actually tell us what the vertex is. So the purpose of that is if I asked you to find the axis of symmetry without graphing it. Okay? So to do that, I would take this value and so first I write A and B. So yesterday in our lesson, remember I pointed out what A and B and C were, okay? So again, C is my y-intercept, A would be 1. So this right here, again, this needs to be memorized. All you're doing is you're plugging those in, and that gives you the actual axis of symmetry for you. All right, so we are going to graph this function. Okay, and then I'm actually going to calculate the axis of symmetry for you on the paper as well. So 3x squared plus 6x plus 5. Now, again, the purpose of this isn't to frustrate you to do more work. Basically, the reason for this is if you get a short answer on the Regent that asks you to show your work, they don't want you to merely just write down the answer using your calculator. They want you to show your work using the formula. Okay? Again, this is all to help you, I swear. All right, so go ahead and make your table. 2, 0, 5, 1, 14. I'm going to circle my vertex, and this is the y-intercept. Okay, so what I'm going to do before I actually graph this, I'm going to find the axis of symmetry using that formula that I just gave you. So x is equal to negative b over 2a. So a is equal to 3 and b is equal to 6. All right, I need to know that. So now you're just substituting in. So I get negative 6 all over 2 times 3. So x is equal to negative 1. So that is my axis of symmetry. My y-intercept is 0, 5, or just a 5. My turning point is negative 1, 2. If you noticed when I did this, if you look at your graph, there is no 0. Okay, there's no zeros. So you can go ahead and write none. This is going to be a minimum, and the range is going to be y greater than or equal to, since it opens upward, and 2. Okay, so I found all of this without actually putting my graph down on the paper. All right, so I am going to put the graph down though. 1, 2, 3, 4, 5. 1, 2, negative 1, 2, and then 0, 5. Alright, so that's as far as I'm going to go. Okay, so f of x is equal to 3x squared plus 6x plus 5. Okay, so again, that is the axis of symmetry. Alright, so I will draw that right in. And notice I'm drawing this as a dotted line. I would like you to do that as well. So you see that that is x equals negative 1, and that is all we are looking for. It's all I'm looking for. All right, so just to move a little faster for number 1, again, we have, so negative x squared plus 1. For this one, again, there's no x value, so b is equal to 0. Okay, so when you do your axis of symmetry, you actually get x is equal to 0. When you plug this into your calculator, here's your table. You have your roots, you have your vertex. For our range, remember, we look at this, it's going to be less than or equal to, and then you take the y value of your vertex. Okay, I know I'm going through this kind of fast, but again, I'm just trying to point out all the different types of questions you will have, or you may come across. All right, for question number 5, I'm going to have you put this into your calculator, so go ahead and do that. Alright, and when you have something like this, this is actually called Vertex Form. We'll do that a little bit later on in the unit. Okay, so I'm going to do x plus 2. Notice I put that in parentheses. Okay, do that squared and then do minus 25. Remember, make sure you hit the minus, not the negative. Okay, so you go ahead and look at the table, or you can look at the graph. So I'm trying to figure out what my roots are. So if you look at this, I have a root here and I have a root here. Okay. So I see I'm further on the negative than I am on the positive, so it can't be either of those. So now I just have to count. So 1, 2, 3, 4, 5, 6, 7. So negative 7 and positive 3, so choice 4. So, I mean, when you get questions like this, the biggest thing they're looking for is, do you know what a 0 is? So a 0, a root, y-intercept. Okay? I'm sorry, x. Sorry. X-intercept. Okay, so when y equals 0. Alright, so those are what you are looking at. And that is a question you just need to know. You need to be able to look at that question and understand what it's asking you. Okay, so let's graph one more. And we'll do this together. I won't just show you the work for that one. Okay, so again, x squared minus 2x minus 3. Go ahead and graph that. Now I know I didn't ask you to do the table, but remember, I always recommend that you do the table. Okay, so we'll do x, y. I'm going to start at negative 1, 0, so that's a root. 0. Oh, that's not what I meant to do. I don't know if I'll have room to write that, so I'll write that later. Okay, 1, negative 4, 2, negative 3, and 3, 0. So go ahead and circle your vertex. I have root, yeah, much smaller, good. Y-intercept, and root. Okay. The next thing I'm going to do is I'm going to find the axis of symmetry using algebra. So a is equal to 1, b is equal to negative 2. So again, write x equals negative b over 2a. Remember, that needs to be memorized. Okay, if I have a negative with a negative, remember that is actually positive. Okay, so negative times a negative 2, that would be a positive 2 divided by 2, so my axis of symmetry is actually a 1. So x equals 1. Okay, so x equals 1 is my axis of symmetry. My turning point is 1, negative 4. Y-intercept is 0, negative 3, or just negative 3. My roots are negative 1 and a positive 3, or go ahead and write those coordinates. My range, I'll do that in a minute. Okay, the max, this opens upward, so this is a min, not a max. So go ahead and plot those. Okay, so I plotted those. To do the range, again, either on your calculator or on this graph, it's just easier if you actually look at the drawing. So remember, this opens upward, so it's going to be greater than or equal to, and we take the y value of the vertex. Okay. Okay, so your homework tonight, oops, sorry. Okay, so homework is just going to be pages 9 to 10. Make sure you do all of those. Okay? Please make sure you find the, going crazy. Please make sure you find the axis of symmetry algebraically. Okay?